Friends, welcome to my YouTube channel Raju. In this video, I would like to teach ANSYS Fluent tutorial for the flow through a two-dimensional pipe. This is the first video from ANSYS Workbench. So please watch fully to understand how to create a mesh, how to create a geometry, how to do the solver setting, and how to do the post processing technique. Come, we'll enter into the video. First, we need to open the ANSYS Workbench. Before that, I would like to tell few things. This CFD is very useful for many engineering branches such as aeronautical engineering, aerospace engineering, mechanical engineering, automotive engineering, chemical engineering, etc. So this video will be very useful for this department as well as for the researchers also. They are using this software. Okay, in previous video I showed how to download the student ANSYS version for from the internet like ANSYS. So please watch that video also for downloading the ANSYS. Okay, let's start. So we need to type the workbench, then ANSYS workbench will come like this. Then we need to click over here. Now it will open the ANSYS workbench. Due to low configuration of my system, I would like to teach with less number of meshes, small amount of meshes with less numbers. So this video is for teaching purpose only. So if you want to do the research and you want to do the more simulation using the software, means you need have the better computational facility. So if you have the better computational facility, you can do n number of applications in this software. Okay, so this is the recent version ANSYS 2020 R2. So this is a student version. While opening the software, it will load like this. So now it's initialization project, so it's like the stage of end. So I would like to teach flow through a two-dimensional pipe for understanding purpose. We will go from step by step, geometry and mesh creation, then solver settings and post processing, etc. So let's open. There are two different designing software is embedded with this ANSYS 2020. One is Space Claim, another is Work Designer. Okay, Workbench Designer. So I would like to teach in the Designer, since I am using this software many years. So I will teach in the ANSYS Fluent through the design module. Okay, now this is how the initial project will open here. So there are n number of options will be available here. These are the tools available for the different modules available for the from the ANSYS software. So let's go into the different module. There are lot of options is here. So let's I will teach fluid flow using Fluent software. Okay, there are different options there. If you are working in by electric and explicit dynamics, there are a lot of blow molding, like extrusions. There are a lot of options there. So I will teach the answer is Fluent for the fluid flow analysis. So we need to drag it over here to create a project. Okay, this is a project schematic. Here we can see the different options available for this, like geometry followed by the meshing, setup, solution, results. So these are the important steps for the Fluent, for the solver setting, Fluent simulations. So now we'll open the geometry. If you go here, right click here, there are option will be there. Right click here, you can see new space claim geometry or new design modeler geometry. You can import the geometry from any other software, like geometry created by the any other software such as like CATIA or Solid Edge or SolidWorks, etc. So we'll use the design modeler. Okay, so now it's starting the design modeler. It will take some time. Okay, we'll see. So design modeler is open here. So we need to create a sketch under modeling. We can go with the sketch. So we'll pick the proper like axis. Okay, XY coordinate section. Since this is a two-dimensional geometry, we will create a rectangle. That will be enough, right? We'll do the edition later. Dimensions, general. Okay, this one and this one, right? We will go with addition. This is showing in the meter, so we will convert that into the millimeter. Okay, right. We'll keep 10 mm pipe diameter, and the length we'll keep 500 or 300 mm. Okay, 30 times horizontal 5. Okay, so to capture efficiently, I created the 30 times of the diameter. So this is the diameter. We have the 10 mm we can see here, and 300 for the horizontal one. So we will go to the fit to window. This one we will drag it down. Sorry, this is we will move it to the right place. Okay, generate. Generated. Again, this we need to convert this line into a surface. Okay, then for that one we need to go to the concept. Okay, surface from sketches, right? Yeah, we need to select the sketch. So here we need to press the control button to select, then you apply, then you generate. You can see two-dimensionally it's created, right? Yeah, now we need to create a domain names like inlet or outlet or interior or wall. So we need to create the domain. For that one we need to select the part and right click. We need to check what are the format is there. Right now nothing is there. See, then we need to select the edge button over there, and this one select and right click over here and named selection, right? Here we can give inlet or velocity inlet, velocity inlet, right? Yes, then generate. Then yeah, in this one we can see part also. No, here we can see velocity inlet is created. We can select it and we can check, right? Then top and bottom, this both are a wall. Okay, here we need to consider that as a wall since we are sending the internal flow. So pipe also we will have the wall only, right? Yes. Then we will move this to the proper exit position. Sorry. Okay, a proper exit position. Then we need to select the edge button again. We need to select this line and right click, go to the name selection, give pressure outlet. Yes, you are okay. Done. Now naming also done. Then we need to go to the workbench again. Here we can see if the geometry is created, it will give the green tick mark. So before that we will save our project, right? Save project. So we will go to the F and CFD tutorial. We will create one folder, flow through a long 2D pipe, right? Yeah, this is the project name. So here we can save the same, right? Yeah, just you have to copy, and in this one we will save as this. In the corresponding folder we are saving the same name. Okay, the project is saving now. It will take some time. Okay, done. Then we'll go to the mesh path. The design modeler is completed, so we'll close this right now. Otherwise my computer won't take much more softwares because my configuration is system configuration is very less. Now the meshing like software is opening. I will pause it right now. Yeah, we can see the mesh file is opening over here. We will check, we will keep the proper positioning. Okay, okay, right. Then we will go to the zoom selection, zoom box. There this is option pan, move, rotate, zoom in, fit to window, right? Yeah. So this is the geometry what we created over here. So we have the all the sections what we created here: velocity inlet and pressure outlet. It is in the reverse direction showing. Okay, velocity inlet, pressure outlet, and wall. Okay, fine. All are there. Now we can do the meshing, right? Yeah. Here we can see, because since we are opening directly the fluent option is showing the fluent option, else we need to change the different step, right? So element size, default size is there. If you want default size, you can keep default size, or else you can do the sizing also. There are different options there, inflation also there, quality also there. So first we'll do the using adaptive sizing. Okay, inflation. This is use automatic inflation none, or else you can use the different model is there. Okay, right now we will use the, because since this is very simple geometry, we can use the element size. So we created 10, right? So into 0.1. So Fluent linear, yeah, we will have the quadratic one. Format standard, large support standard will be sufficient. So element size, so it is taking in meter, so we will keep 0.01. okay, no sizing, use adapting, this one no need right now, we will do it later. First we will go with the simple solutions. Okay, simple we selected and generate mesh. Meshing is 5% is completed, 100% is done. Since we need to reduce the mesh size because it is showing the one unit only. Okay, we'll use one more 0 here. Now it will take one more, like 10 partition over here. We will get the 10 partition. This dimension also we will get the 10 partitions. Okay, we will generate over here. Now also it's doing mesh. So based on our requirement, we can do the different meshing option. Right now I am using the uniform meshing with quadratic element. Okay, meshing is processing. So we'll see how the mesh will be there. Yeah, so this mesh is looking good. So here what I told is it divided into a 10 part because this is a 10 centimeter. Alright, oh my god, see here you can see 10. Okay, yeah, now mesh also done. We'll go to the post processing, processing in the Fluent, right? We will close this also right now. Meshing is done. In the workbench we can see update project, then it will tick into the green color, it will come into the green color. See, it's updating our project, means like the process. Okay, it will take some time, it's updating. Now we'll go for the setup and solution results. Okay, it's taking some time, we'll wait. Okay, so after mesh we can use the setup. Then yeah, I already told you, right? See, after completing this one, it will come on to like this. Then update solution. Now some error will come because we are not done the simulation, but it's taking the process all the stuff. We'll see what it will do. Yeah, I already told you, right? We need to open the Fluent. See here, you can see we need to open the Fluent for the setup. I am giving all the access. It's updating the information, initialization, solution solving. It is doing something. Yeah. So okay, fine. Updating solution. It won't be there. Number of iteration greater than 0. We not done any solution, right? Yeah. I know this solution will come. Since we need to open the setup. Now it will ask the Fluent open. Yeah. Now we can see there are different options available here. Two dimensions, since we are working in two-dimensional domain. Double precision, display mesh after reading. This one no need to select, since we are using like smaller mesh. It's okay, fine. If you are using very bigger mesh, it's difficult to handle the system, so no need to select. And we will run in the parallel process. Let's take, I will give simply 8 process. So more option, no, we will start the, we'll see what other option is there. 3 process, 0 Fluent, this and all some process, and where the okay, so let's and start. Now Fluent environment will open for the processing setup. Okay, we need to do the settings for the flow through a pipe. Let's say we'll check how the mesh quality and all here. Then we will move to the processing and post processing. This and all what it's doing, simply navigations, because this is the first time we are opening, right? It's showing some updates and all. It is loading our meshes into the Fluent environment. See, there are new options available over here. We'll explore the new options, right? My system configuration is slow, it's taking some time. Two D read into double precision. Okay, it is taking some solver information also there. Okay, fine. So we will explore here mesh, right? We will check the mesh quality and all. Sorry for this advertisement. So we will check. So these are the mesh information for our domain. Okay, this is like 10 mm and 30 centimeter. And mesh we check, and we will do the size. Okay, mesh info, right? Mesh info, grid level. Sorry, it's taking some error. Yeah, the number of cells 3000 cells is there, total cells. Otherwise we will go to the info and site checking. See, the number of cells is 3000, so we can increase the more number of cells using adaptation technique, where that will be there here. Results, dynamic boundary conditions, mesh interfaces, dynamic mesh. There are a lot of options is available in this one. Pressure based, planar, we will go to the transient, and gravity enabled. Sorry, I am getting one call, just a minute. Sorry for the disturbance. So we'll keep the gravity. So in this one we will keep the y direction 9.81. we will keep like transient 2D pressure based. We will use the pressure based solver. Units, we'll check what unit it is there. Okay, this and all, no need to do the conversion right now. General is over, right? This is general about this one task page. And quality, we will check the evaluate mesh quality. These are the quality mesh details. Minimum orthogonal quality is this one, and maximum is to improve the orthogonal quality, improve reverse in the fluent meshing, where these are the new option available here. We will go with the regular procedure. Model multiphase, no need. Here viscous, it automatically taking. There are different option here, inviscid and laminar, smart mesh and all. It's taking like k omega. We'll keep SST k omega model. We'll keep the same one for our simulations. We can do the simulation for the different cases here. See, you can the detached simulations. And here also, because if you want to do the research over here, you can do multiple options here to check the proper model. Since this is the new, like this is for the teaching purpose, I will keep as it is. Okay, if you want to more detail about this, please give the comment in the comment section. I will I will do the like more detail about that one. Okay, that is done. Then viscous is done. Modules is mostly right now done. We will go with material also is there. The material will fluent hair only. It will open the metal property of the hair. Viscosity, density, all are the same stuff. Okay, we'll keep as it is. Then cell zone conditions, we are not doing any stuff. Okay, boundary conditions, we'll go velocity inlet, and type is velocity inlet only. Edit, we will keep velocity around how much, like we will keep 10 meter per second. Okay, we'll keep this one. And the intensity, turbulent intensity 5%, turbulent viscosity ratio is 10. We'll keep as it is based on the stuff. So here there are option magnitude normal to the boundary condition. Since our flow is going normal to the inlet velocity, sorry, the boundary condition of the velocity inlet, we will keep the 10 meter per second. Apply, close. Okay, done. Boundary condition is done. Then we need to do the solution initialization, right? Yeah, we will use the standard, and from the velocity inlet, here it's calculating the different parameter based on the input condition from our velocity. Now it's initializing the stuff. Right now calculation activities, we can do the autosave, edit, autosave for every 10 time steps. Okay, okay, fine. Every 10 time step it will save the case and sorry, case or data. Okay, it will save the case and data file. Right now autosave is done. Solution animation, Animation means we need to do some more setup. Right now no need, I will show it in the future one. So right now the initial steps are done. Now write solution, uh, run calculation. Now we need to give the delta t, number of time step we'll keep like 1000 for this one, and 0.1 means we will run the numerical simulation for 100 seconds, right? Then we will keep this as a 1. If you want to get the accurate solution, you need to change one to different module. Okay, right? We set it export. Sorry, we need to do this one, data sampling for time statistic. This will be very useful for the post processing, means like to calculate the mean and RMS velocity for the different time step. So we did this one. Meanwhile it will save, right? Read, sorry, export case and data. Okay, fine. Flow through a 2D pipe. Yeah, for reference we will save the start. Okay, means it will save for the start condition, case and data for our numerical simulations. So if you want to change the velocity parameter for the different, and if you want to change the any other parameter, you can easily change that in the start, the what we saved over there. Then we will do the stuff. Now we will do the calculate. Okay, fine. Calculating the solution. Yeah, we'll see how the stuff is coming. Okay, I will pass it here. Once the simulation is completed, I will show. Okay, dear friends, we have so much better option than the previous versions. Here you can see how much percentage numerical simulation is completed. 28% is completed, and still remaining how many iteration is remaining is there. Based on that one, like it's calculating goes. So they updated well in the software. We'll see. Okay, in the post processing we'll pass it here. Yeah, after like our record calculation is showed calculation complete. Okay, based on our stuff it will save the case and data for every given time interval. So we will go for results. We will see graphics, right? Yeah, we'll go for contours. Okay, we will be filled. We will show the velocity. I need to display. Yeah, so this is how the velocity magnitude will be there for the two-dimensional pipe. Okay, yeah, so we can save this as how we can save this one. If you want, you can export and copy screenshot to active video to clipboard. We have the options. You can clipboard here. So it will save us this 1. Okay, so downward direction for the mouse center is like zoom in, forward front direction is, upper direction is unzoom. Okay, this is the new software adapting done. Okay, we will now see the velocity vector, how the velocity vector is there for this turbulent cases. We will see. Okay, velocity vector display. Okay, here you can see how the growth is happening. Initially there is a uniform flow. After increasing in the axial direction, the velocity also getting increasing. At the exit we can see yeah, at the exit we can see the maximum velocity at center. It is forming kind of the good velocity profile for the fully developed flow for 3. So we can do path line, all the stuff we can do. Here there will be one option to this will minimize boundary condition, will solution methods, monitor will solution method, minimize fonts, animations. This one will not set any parameter over there, so that's it. Similarly we can see the different pressure or any stuff, we can see it here, color by pressure also now we can see display. So this is a static pressure information. Yeah, so this is the velocity vector for the pressure. So the magnitude wise it's showing the color. Okay, right now the process is done. It saved the corresponding case and data also. So I will stop it here. You can do export. I will try to show it in another software called TechPlot for this better understanding. Right, this is the pressure, and similarly we can go the graphics, and the path line will be same. Anyway, we'll set up the path line. Okay, we'll skip some of the stuff. Okay, we'll skip 200. Okay, we'll select all and display. Now it will show the, because this will be simple straight line, right? Yeah, simple straight line only, since flow is straight. Yeah, this is the straight line. So I will stop it here. If you want more detail about this simulation, we can explore more. So I will do the 3-dimensional with the same diameter and length. We will compare the velocity profiles for corresponding distance from the inlet. Then we will see how whether like 2-dimensional is good or 3-dimensional is good. We will see. I will see in the 3-dimensional in the next video. Thank you so much for watching. Please share and subscribe to get more information about CFD. Thank you. This is my first video. Thank you so much for watching again.